What's the biggest man-made object ever put in the water? Movie fans might instantly think Titanic. Modern cruise fanatics would be drawn immediately to the icon of the seas. At over 248,000 tons, that's the largest, heaviest cruise ship ever built. It dwarfs the Titanic, which weighed only 52,000 long tons. Most people, though, would immediately think aircraft carrier. Surprisingly then, the modern Nimitz-class aircraft carrier displaces only around 104,000 long tons. 106,000 long tons when it's fully loaded. No, if you're looking for some extreme oceanic engineering, you're looking in entirely the wrong place. And you need to think a lot heavier. 1,601 feet, or 488 meters long. 243 feet, or 74 meters wide. And 344 feet, or 105 meters tall. Made of 260,000 tons of steel and displacing some 660,000 tons when fully loaded. That's more than 6 Nimitz-class aircraft carriers stacked on top of each other. The most heavyweight engineering project ever floated isn't really even a ship at all. It's the Shell Prelude floating liquid natural gas platform off the coast of Australia. Behind any extreme engineering project lies a single big question. Why? Why would we put in the time, the effort, and the money to build something? So why was it deemed necessary to build the Shell Prelude at all? Why put it where it is? And what is it expected to do while it's operating? There are some easy answers in the case of this mega machine. The Shell Prelude is a modern floating liquefied natural gas platform. That means its job is to suck natural gas out of the earth through wells. Then it liquefies the gas by chilling it to minus 162 degrees Celsius. And the process needs to end with the LNG being transported by specialized cargo ship. So the location of the Prelude is dictated by the location of the natural gas fields. That makes sense of it being sited amid the Shell Prelude and Concerto Fields. The fields are 124 miles or 200 kilometers off the coast of northwest Australia. That helps in terms of both getting the gas and shipping it immediately. But it brings its own challenges. The area is well known for significant storms, which is a polite way to say it's in the Indian Ocean's cyclone alley. That's hardly ideal if you want to put an LNG rig in the ocean. The size of the Shell Prelude is governed by the expected productivity of the field, and by the resistance to those storms that an enormous platform can bring. The physics of scale come into play. A storm has to be bigger to disturb a huge platform than it does to rock a smaller vessel. The Prelude and Concerto fields hold around 3 trillion cubic feet of extractable gas. They're expected to produce 3.6 million tons of liquefied natural gas per year for 25 years. Which answers the question of why the Shell Prelude is where it is. Easy access to all that gaseous money makes it, at least theoretically, a worthwhile investment. But it was of course by no means built in situ. Building a massive mega platform in Cyclone Alley would be several disasters waiting to happen. Begun in 2012, the megastructure was built in the Goji shipyard in South Korea, one of the only shipyards in the world big enough to do the job. More than 5,000 people worked on the Prelude's hull each day for over 12 months. Other enormous elements of the platform's construction were completed separately around the world. They were fitted together like the world's largest Lego project. That meant construction time could be cut down. But it still took until 2017 for the platform to be completed, at an estimated cost of $17.5 billion. In July 2017, the colossal platform was transported from South Korea to the Australian coast. But that was just the beginning of a whole new phase. The Shell Prelude actually marks the start of Shell's offshore LNG production. so everything has to be right if it is to prove itself a blueprint for the future. But that flies in the face of the laws of both engineering and probability, as Shell discovered almost immediately. While it began producing LNG relatively soon after its arrival on site, the Prelude has been riddled with teething troubles. It began pumping in December 2018, but by 2020 it had experienced 2 gas leaks. Then, in February 2020, an electrical issue shut the platform down. It didn't restart until January 2021, almost a full year later. In December 2021, a fire meant the Prelude lost all power and evacuated most of its crew. It took until April 2022 to restart that time. And later that year, industrial action shut down production for another 11 weeks. In August 2023, the Prelude was shut down again after what Shell described as problems with its process. It didn't restart until January 2nd, 2024. All of this is somewhat ironic given the high-tech engineering that's gone into making the platform safe from Australian storms. The process involved in that safety is truly groundbreaking. The platform is moored through a central rotating turret that's connected to no fewer than 16 steel piles driven deep into the seabed. Each pile is 235 feet long and 18 feet in diameter. The platform is connected to the piles by nearly 25,000 links, of some of the most hardcore chain in the world. Just 8 of them need to be locked in place to make the platform storm-safe. The remaining 8, presumably, will keep it safe from more dangerous upsets. Everything from seabed disturbance to the release of a cranky Australian kraken. It's strangely emblematic of massive engineering projects that so many people can spend so much thought countering potential danger only for small fires or industrial action to halt production for extended periods. In fact, given its teething troubles, it's arguable that now the chains are in place, Shell could reap rewards by installing a state-of-the-art fire suppression system. But now it's up and working, let's take a look at some of the statistics that make the Prelude so remarkable. The Prelude uses steam for its power generation and for driving compression applications. It has 7 of the largest capacity boiler units currently in marine use. Each one delivers 220 tons of high-temperature and high-pressure steam per hour. Prelude's centrifugal compressors use a single casing double-section back-to-back design. That reduces the train length and weight of each compressor on the Prelude. The compressors are designed to handle nozzle loads corresponding to a Category 5 cyclone. That means each of them had to go through stress evaluation and displacement checks. The Prelude uses 3 42-meter, 100-ton bollard pull infield support vessels, or ISVs, for LNG exports. It has 4 high-pressure, high-temperature dynamic flexible risers. They're designed to survive a 1 in 10,000-year cyclonic event. Or that kraken we mentioned. These risers can draw 50 million liters of cold water from the ocean every hour. That's needed to help cool the natural gas into liquid. In terms of motive power, the Prelude has 3 Rolls-Royce USL 455 azimuth thrusters. The electrically powered 6,700 horsepower thrusters are fitted at the rear end of the vessel. They operate 2 at a time to turn the facility out of the wind. While it remains heavily chained to the subsea piles, they also allow LNG carriers to pull alongside to load. The Prelude's turret is 100 meters high and weighs 11,000 tons, with a diameter of 30 meters. That makes it the largest turret of its kind in the world. Now the Shell Prelude is in place and pumping, its future looks to be set. It's been designed to deliver 25 years of LNG production, so the shutdowns in its first handful of heartbeats are really just teething problems. The question is whether it will retain its title as the biggest thing afloat for long. Back in 2013, when it was still just a glint in Shell's eye, the idea was that if the Prelude was an economic success, it would be just the first of many such mega-platforms harvesting gas from oceanic sources that were too distant or too tough to get at any other way. 11 years on, though, such talk has grown quiet, and no successor to the Prelude has yet been launched or even announced. Could the Shell Prelude stand alone to defend its record until the end of its active service? Keep your eyes on the Indian Ocean and on the overall viability of long-term offshore LNG production platforms.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.